Hey there, Math 112 fans. I'm trying all different sorts of things to see what resonates the most with you when it comes to studying. So I've already done some detailed videos by topic. Now I'm going to just show you working through an old exam quickly. Like, I'm not going to do as much explaining. Let's just talk through a good exam quickly. I've got my calculator ready. Let's go. And then I'll probably come back and make a separate video where I talk about more of the background. All right, so here's an exam. You open it up. Write your name, put your signature, you open the first page. If I was a student, I would immediately start taking the derivative. And we know the steps. The steps are to rewrite it. This step is not completely necessary, what I just did. So I guess if I'm trying to go swiftly, I'm already not doing it. But this is it. Then you have 3 jobs to do. The derivative of the first, and we've done a lot of this. So this is the moment when things really should be starting to accelerate. And then you get to this messy term. We have a first, we have a second, it's a product rule, first times derivative of the second. The derivative of the second is going to take a little more work because it's a chain rule problem. But at the time you're taking this test, you would have already done a bunch of those problems. So that's the first times derivative of the second, plus the derivative of the first, which is 48x to the third times the second, x squared plus 8 to the 1/2. And then we're going to plug in a 1 everywhere. Since we're plugging in a 1, it's kind of nice. It's just 5 plus 6 plus 12 times 1/2 times 2. I'd probably cancel that, but I'll show all that here. You'd have a 9 to the negative 1/2. And you can see I don't try to plug all that into my calculator. I first try to write it down, and then I make a plan for how I'm going to plug it into my calculator. In fact, I'm not going to plug it in my calculator at all because this is 11. This right here is the square root of 9, which is 3. Those cancel. And this is 1 over 3. So this is actually 12 times 1 over 3. So to me, writing down was way better than reaching for my calculator, way faster. And the last thing I need is 48 times 3. Only then would I reach for my calculator, and I probably would type in 48 times 3, and then add 15. So we have 159. And we'll go through and check in a second, but for now I'm just working. Okay, so then we have a foundational question. Now my students know that won't be on page 1, it'll be on a different page, but that's for this particular class. I'm trying to make a general video. So you would just start writing. Okay, g of x plus h, x plus h minus 4 minus, and this was the foundations. Again, if you want to know why, I'll come back and do that in a separate video. And then it's just algebra. And there's several things we know what to look for. So this is going to be x squared plus 2xh plus h squared. At this point, we should know that pretty well because it's happened quite a bit. That's what this is. So if I was doing this, I would just distribute the 3 right now and say 3x squared plus 6xh plus 3h squared. That's all that stuff. Minus 4 minus 3x squared plus 4. And now we know what should happen. Everything that came out of the second parentheses here should cancel. Let's see if it does. Yes, yep, yep. And now one of the h's should cancel out of each one, so you get 6x plus 3h. That's what goes here. And then if you plug in a 0, you should get the derivative, but you should also check, because you know another way to do the derivative, that they match up. So you have many ways to check your work. On we go. Find the equation of the tangent line. So in this case, the original function was, what was it? 3x squared minus 4. And now we know the derivative is 6x, and we're plugging in 2. So we know the equation of the tangent line, the equation of any line, looks like this. You just need the slope and the height. What's the height? It's g of 2. So that's 3 times 2 squared minus 4. 12 minus 4 is 8. And here if you plug in a 2, this is g prime, sorry. G prime of 2 is 12. Slope is 12, height is 8. And you can leave it like that or expand it. On we go. So then we get this application problem. Now students know what the applications are going to be this particular quarter because I've told them on the discussion board and on my announcements and in class. So there won't be a balloon question, but the ideas here are the same. The main thing in this question was they were telling you this is the derivative. And here I even added it again. So they're not telling you the height formula. They're telling you its derivative. It's this negative 0.5 t squared. And my students know that this comes directly from the homework, and that I'm someone that likes to ask questions directly from the homework. Anyways, so when you ask this question of what's the longest interval when it's rising, you have to translate this. Balloon A rising means A of t, the height, is increasing. You just have to read. There's no way around that. So this means height. This means velocity or rate of ascent, however you want to say it. Or slope. Okay, we now know that that's increasing when its derivative is positive. And that's where it's important you realize they gave the picture of this, and positive means above this axis, which happens from here to here. That's when the graph is positive. That's when the derivative is positive. So the hardest part there was just understanding that, and now it's time to solve. When is negative 0.5 t squared plus 6.5 t minus 18 equals 0? Honestly, if I was doing this, I'd multiply everything by -2. That's kind of a clever maneuver because I just like to get rid of all the decimals. I don't know if that's good for me to do in the video. I just saw that if I multiplied by everything by -2, I get whole numbers. You could work with the numbers you had. Actually, it's not that bad when you plug that in the original one into the quadratic formula, so maybe I'm making a mistake. Anyways, if you don't know how to factor, then it'll be time to do the quadratic formula. Negative b plus or minus square root b squared minus 4ac all over 2a. And then you just do a couple bits of calculation. This is something you should be practicing as you're doing the homework, but it should be 13 squared. And you can see how I don't try to type it all in. I do it in pieces. That's what I've demonstrated in class. That's the first thing I would hit. That's the stuff under the radical. At this point, I wouldn't write it down if I was a student because I can see it's nice. But I always compute that first. Then I hit the square root button. Now here I know what it is. It's going to be 5. So I have 13 plus or minus 5 over 2. And there's two possibilities. There's 13 plus 5 over 2, which is 9. And there's 13 minus 5 over 2, which is 4. 4 to 9. So the main thing there was realizing it was asking when the derivative was 0, and not was asking when the derivative was positive, but you have to find when it's 0. Give the time when balloon A is rising fastest. What does rising fastest mean? It means it's the biggest speed, the largest speed. It's when this is biggest. So this question we're trying to kind of keep you honest. We want to know where that is when that's highest. There's a couple ways to do that. You could find the vertex, or you could find the derivative of that thing. Now, that bothers people sometimes when I do it this way, because you say, well, that's the derivative of something else, but it doesn't matter. The question's asking where that point is. Anyways, set this equal to 0, t is equal to 6.5. Done. We get another balloon given by this. How fast is balloon A moving when balloon B is at its highest? So sometimes the more words there are, the more people give up. Don't do that. We need to find the time when balloon B is at its highest, and then we need to figure out how fast balloon A is going. So you already can see a path. We need to figure out when the altitude is the highest. The highest is going to be one of these bumps. So we need to find when the derivative, which is this, negative 3t plus 24 equals 0. So we get t is 8. And then the question is asking at that time, how fast is balloon A moving? That's the speed of balloon A. And the speed of balloon A we have up here. Negative 0.5 t squared. Squared. And what's the rest of it? Plus 6.5 t, which is 8, minus, I think it was 18. I'm so quickly forgetting. So a little bit of calculation. Again, I probably would do it in pieces. I would do 8 squared. 64, I don't know why I did that. times 0.5. So this would be negative 32. And you can see how I really like to compute it in pieces so I can keep it together. So 8 times 6.5. This isn't just because I have a basic calculator here. It's just so that I can kind of check as I go. This is plus 52. So use that pencil or pen. So I need to do 52 minus 32 minus 18. 2. Let's keep going. I'll come back and check those answers in a second. I'm just showing me as a student working through the exam. The average cost of this, find and simplify those formulas. Now this is a little bit more of a Math 111 question from the old days. We did this, but you're just dividing this by x. So dividing x cubed by x, you're going to get x squared over 12. Dividing x squared by x, you're going to get x. Dividing x by x, you're going to get 1. And they're going to have this 1 over x. That's what goes here. Now, in order to do the derivative, you have to do all the stuff we've been doing. Let's rewrite it so a calculus student can do it. Okay, now we've rewritten it. And now let's take the derivative. AC prime is 1/6 x plus 1 minus x to the negative 2. There's a little thing in this problem that's more of a holdover from the old course. But if somebody says something is in 100 items, and then later on in the problem it says 200 items, you have to think what goes there. And the answer is x is 2. So you should realize this is asking about the marginal revenue, but it's the marginal revenue at 2 just because of the units. 200 items is the same as 200 items. Okay, so we want the marginal revenue. Oh, we need the total revenue first. Total revenue is price times quantity. Marginal revenue is 10 minus 2x, and we're plugging in a 2. So 10 minus 2 times 2 is 6. Give the longest interval over which total revenue is increasing. So total revenue is 10x minus x squared. We should be able to answer this in a number of different ways. One is that it's a parabola, so we already know that. The other is that we know things tend to stop increasing when the slope is 0, and we know that's when the derivative is 0. So we now have more than one way to answer some questions. But anyways, then you get x is 5. So when is it increasing? It's increasing from 0 to 5. I remember some students put negative infinity here, and I gave them full credit. At what quantity and selling price is profit maximized? The question mentions profit. So if it was me, the first thing I would do is I write down the formula for profit. That's not the only way to do it, but I think I want it. Let's see. So that minus the cost, that's x 1/12, x to the third. And I'm not saying that I did the optimal way. I'm just trying to encounter it like a student might. So one thing you might do is try to do the profit. Another thing you might do is marginal revenue equals marginal cost. All of those are fine. Okay. In fact, I think I wish I had done marginal revenue minus marginal cost because I don't think I want to simplify that. So now I'm going to switch gears and find the marginal revenue, which we know is 10 minus 2x, and find the marginal cost, which we know is, I think we already computed this. Oh no, we didn't compute this. X squared plus 2x plus 1, and then find when those two things are equal. Well, that's an opportunity to use the quadratic formula. X squared plus 2x plus 1. Get everything to one side. 0 is equal to 1/4 x squared plus 4x minus 9. I personally would multiply everything times 4, but that's maybe an advanced trick. It's an unnecessary trick. And then we get to do the quadratic formula again, or if we know how to factor, we could try to do that. Negative 16 plus or minus 16 squared minus 4ac all over 2a. And then you know the techniques. Because the other thing is, hopefully in the homework you've been practicing this, getting more efficient with using your calculator. Squared, it's going to be minus minus, so it's going to be plus 4 times 36. There. And we do a lot of this in our Math 111 class. Hopefully you've practiced using your calculator. That's what that is, 400. And then you can hit some cool things. Second square root, second answer, fun. That's 20. So you have x is negative 16 plus or minus 20 over 2. And then how do we finish it off? Well, there's two quantities, and one is negative. Because if you do negative 16 minus 20, it's going to be negative, so that's not it. So it's going to be negative 16 plus 20, which is going to be 4 over 2. This is 200 items. I remember students getting really confused by this other one because the question says, what's the corresponding price? And they plugged into profit. But that's not the price. The price is up here. 10 minus x. So the price is 10 minus x, and x is 2. So this is 8. All right, that's it. I don't know how long that took. I don't take too long. And then okay, that's it. Let's take a look at the solutions. Make sure I didn't do anything silly. 159, that's what we got. 6x, that was the derivative. 12x minus 2 plus 8. I think that's what we got. Let's go back up and look. 12x minus 2 plus 8, lovely. Then we found it was 4 to 9 and 6.5. 4 to 9, 6.5, great. This was 2 feet per minute. Oh, I forgot to put the units. There's those formulas. We got 6, we got 0 to 5, we got 2 and 8. Let's go check. That's it. So I'm going to go back through and talk about some of the details, but I'm going to stop the video now.